Hi everybody. Today we'll have a problem solving on indefinite integrals. But first of all, what is indefinite integral? It is when a function has a derivative of a given function. From this characteristic, we use indefinite integrals to derive various equations or values from a given one, such as the case of vector quantities. From the displacement, we can get the velocity, and from the derivative of the velocity, we can get the acceleration. From this, it's quite evident we need to study indefinite integrals. It's very useful for problem solving, especially since it's quite versatile and can be applied to various topics. Physics, business economics, health, and many others makes use of indefinite integrals. In this sense, we have many ways to predict certain events when it pertains to values and rates. We can gain a vague idea on the amount of certain things like population, money, and resources at a given time, or predict the effect of a epidemic by calculating its rate of infection. But in order to fully utilize indefinite integrals, you have to develop certain mathematical skills. It's important that you become familiar with the fundamental theorem of calculus. We have to follow certain steps in getting the derivative, which can only be done by knowing the techniques that are to be applied as per the condition of each problem. Now for our problem sample in indefinite integrals, we'll take on the topic of environmental science about the consumption of resources. World consumption of silver is running at a rate of 20 e raised to 0.02 thousand metric tons per year, where t is measured in years and t equals to 0 corresponds to 2008. Find the formula for the total amount of silver, S, that will be consumed in 2 years of 2008. When will the known world resources of 570,000 metric tons of silver be exhausted? From the problem, the rate of silver consumption is represented by S prime equals to 20e raised to 0.02 t. From this, we can derive the total amount of silver consumption through integration, which will lead to the equation S is equals to the integration of 20e raised to 0.02 t dt. Considering your 20 is a constant multiple, you can take it out from the integration symbol, leading you to 20 integration of e raised to 0.02 t dt. From that equation, you will have to apply u substitution, in which case your u is equal to 0.02 t, and getting that derivative, your du is equal to 0.02 dt. But then you will have to remove the variable, which you will have to divide it by 0.02, leading you to du over 0.02 equals to dt. This will change the representation of your integration, which will lead you to s is equal to 20 integration of e raised to u times du over 0.02. Considering you have another constant multiple in 1 over 0.02, you can remove that and place it together with 20 outside, leading you with the equation of s equals to 20 times 1 over 0.02 times the integration of e raised to u du. After that, you have to integrate this equation so that you can have s is equal to 1000 e raised to 0.02 t plus t. Considering that your constant is still unknown, you have to solve for t, which we will do so by using the values given on the first part, in which case your s will be 570,000 metric tons, while your t is equal to 0 because you are still just at the beginning. You will substitute these values to your equation, leading you to 570 equals to 1000 e raised to 0.02 times 0 plus t. You need to transpose all the known values to one side so that you will have an equation of t equals to 570 minus 1000 times 1, which is which came from e raised to 0. Computing the values, you will now have your c equals to negative 430. This will change your equation to s is equals to 1000 e raised to 0.02t minus 430. Now we can know the time it takes for the silver resources to be depleted, making your f equals to 0. And then you have to compute for t, which will make your equation 0 is equals to 1000 e raised to 0.02t minus 430. From there, you have to transpose 430 to the other side, leaving you to 430 equals to 100e raised to 0.02t. Afterwards, you have to use logarithm to bring down the exponent, so that your equation will now be logarithm of 430 is equals to 0.02t logarithm of 1000e. With this equation, solve for t, so that your equation will be t is equals to the logarithm of 430 all over 0.02 logarithm of 1000 times e. Computing all this, you will now have t equals to 38.34 years. It will take approximately 38 years for the silver resources of the world to be depleted, which will be in the year 2046, considering that the initial year was 2008.